Hi, my name is Ruby Cotton, and welcome to my presentation on Sequoia and Kings Canyon National Parks, a geological and environmental history. Over the next several slides, we'll explore how these landscapes formed over hundreds of millions of years. By understanding the geology, climate, and history of these parks, we gain a deeper appreciation of their beauty and the challenges they face in the future. Sequoia and Kings Canyon National Parks in the southern Sierra Nevada cover over 1,300 plus square miles of diverse terrain, including foothills, canyons, marble caves, and of course, giant sequoias, the world's largest trees according to the National Park Service or the NPS. They also contain Mount Whitney, the highest peak in the contiguous U.S. at 14,494 feet, and over 800 miles of trails through ecosystems rich with black bears, mule deer, and 200 plus bird species. In the mid-1800s, resource-seeking explorers, miners, and loggers caused widespread damage to ancient sequoias. Conservationists responded, and Sequoia National Park was established in 1890, the first U.S. national park created to protect a living organism, the giant sequoia. In the early 20th century, John Muir's advocacy for preserving the region's natural glacial landscapes led to the creation of Kings Canyon in 1940, and the parks have been jointly managed since 1943. For thousands of years, Native American tribes lived sustainably in the region, using practices like controlled burns to maintain ecosystem health. In contrast, 19th century European settlers caused deforestation, erosion, and habitat loss, but the creation of the parks later marked a turn toward conservation. These parks were shaped by geological processes over millions of years. Volcanic activity during the Mesozoic era formed the Sierra Nevada batholith, a massive granitic rock body that underlines much of the park. Later, tectonic uplift exposed this granite. During the Pleistocene epoch, glaciers carved the valleys and lakes. The NPS highlights features like marble caves formed by acidic groundwater dissolving limestone and marble. These events shaped the park's rugged and diverse landscapes. During the Cretaceous period, Sequoia and Kings Canyon lay along a convergent plate boundary where subduction formed magma that cooled it into granitic rock, creating Sierra Nevada. Marine sediments like limestone, shale later lithified into sedimentary rocks, which tectonic uplift and erosion exposed, revealing granite. Granite features like Moro rock resist erosion, while marble caves formed by metamorphosized limestone are sculpted by water. These geologic processes shape the region's striking topography. The volcanic origins of the park start around 100 million years ago. Subductions of the Farallon Plate beneath the North American Plate led to volcanic activity, forming magma chambers that cooled into granitic plutons, now the Sierra Nevada batholith. Uplift and erosion then shaped the rugged peaks and granite outcrops we see today. Reported by the NPS, the parks are known for the fossilized flora, fossilized remains of ancient giant sequoia trees found in Cretaceous-era settlements. The parks also contain fossilized fauna, fossils of ancient fish and aquatic species, revealing the biodiversity and climate of the region in different geological periods. Ongoing research continues to uncover fossil sites. During the ice ages, glaciers eroded and deposited material, forming U-shaped valleys and rugged terrain. Some key elements are the glaciers that carve deep U-shaped valleys like Kings Canyon, with flat floors and deep granite cliffs. Cirques, an amphitheater-like valley, formed glacier heads, and lastly, moraines, which are accumulations of debris from glaciers, marking the glacier's furthest advance. Most caves in national parks like these are solutional caves, formed by acidic water dissolving marble, metamorphosized limestone. The Sierra Nevada uplift exposed these formations, making them vulnerable to erosion and cave formation. These caves reveal crucial geologic history. Marble indicates past metamorphic activity, while cave formations help geologists trace environmental changes and tectonic events in the Sierra Nevada. The Sierra Nevadas was shaped by tectonic forces and ancient basement rock. As mentioned before, the subduction of Farallon Plate beneath the North American Plate generated magma that formed the granite of the Sierra Nevada batholith. Beneath this granite lies older metamorphic and sedimentary rock. These rocks were deformed during the Jurassic era Nevadian orogeny, which caused significant folding and faulting. This plate interaction was key in shaping the region's current geological structure. In recent decades, the Sierra Nevada has faced rising temperatures, with 2021 marking California's hottest summer. Precipitation has become erratic, leading to prolonged droughts. 2020 and 2021 was California's second driest water year, with the Southern Sierra only receiving 9.9 inches of rain versus the 28.8 average. The NPS reports that the heat and reduced water has stressed many native species, nearly doubling mortality in trees like ponderosa pine and white fir from 1983 to 2004. Droughts from 2012 and 2016 further weakened forests, increasing vulnerability to pests, disease, and fire. Natural disasters and geologic hazards are events that reveal the powerful natural forces of these parks. The lightning caused by the KNP complex fire in 2021 burned 88,307 acres and destroyed up to 2,400 giant sequoias, while the Windy Fire, also in 2021, scorched 97,528 acres and killed around 1,300 large sequoias. The NPS reports that hotter, drier summers and shrinking snowpacks increase wildfire frequency, flood risk, and soil erosion. Warmer, wetter conditions are also causing more rockslides and landslides. The park's granite-dominated geology adds to this instability. A USDA specialist report notes that ongoing tectonic uplift from Pacific North American plate convergence continue to shape the region and raises earthquake risk. In conclusion, I believe that Sequoia and Kings Canyon National Parks are a testament to Earth's dynamic geological processes and the complex history of human interaction with the land. From ancient tectonic movements to volcanic activity to the impacts of climate change and historical land use, the parks have undergone remarkable transformations. As we look to the future, ongoing conservation efforts will be essential to preserving these natural wonders for generations to come.